We are going to factor and solve polynomial equations using quadratic techniques. So you can see on this page I've already started to save some time, as I'll do throughout the lesson so it doesn't get too long. So we have x squared minus 5x plus 6 equals 0, so that's our polynomial. We factor that would be x minus 3, x minus 2. Then we set each one of those equal to 0, because we want to find out where does it cross the x-axis if we would graph that. Those are our roots or our zeros, meaning if we put 3 in for x and solve that, we'd get 0. If we'd put 2 in for x and solve the equation, the original equation, we'd also get 0. So those are our zeros, those are our roots, those are our solutions if we would graph that equation there. So we're going to do something very similar to this, but we're going to have, instead of x squared, it's going to be x to the fourth. So we'll do one more of what we're used to doing with an x squared. Alright, you can see right here I have 12x squared plus 5x minus 2. That's our polynomial equation. So in factored form, that's 3x plus 2 times 4x minus 1. Set each one equal to 0, and we'd solve for those, and we get negative 2/3 and and 1/4. So again, if we would solve those and graph them, then that's where our graph would cross the x-axis on those 2 points. So that again is our roots or our zeros. So we're not going to have to graph today, we're just going to be solving these using polynomial equations. But like I said before, we had x squared, now we're going to get into x to the fourth. Alright, so just to kind of go over with an x squared before we get into x fourth. So in order to get an x squared, we had to have an x here and an x here, because x times x is x squared. So that's how we got our x squared. So when we multiplied these two numbers, or these two variables, x times x, we get x squared. So that's where the square comes from in our original equation. So we're going to do something similar to that with x to the fourth. We're still going to factor if we can, and then solve for 0 to find our zeros and our roots. Alright, so here's our first problem here. So we have x to the fourth minus 5x squared minus 36. So the one right above there, in order to get x squared, we had to have x and x to get x squared. Well, if we want x to the fourth, then we're going to have x squared and x squared there, because x squared times x squared is going to give us x to the fourth. So we're still going to factor like we've always done way back from algebra. So when we factor this, then it would look like this. So if we would FOIL that or double distribute all of that, we'd end up with our original equation of x to the fourth minus 5x squared minus 36. So now, just like in the first two slides there, we're going to take each one of the factors and set it equal to 0, and we're going to solve for them then. So we have plus 9, plus 9. Now in order to get rid of the x squared, we know that the inverse of x squared, if we square root it, that kind of cancels each other out. They undo each other. But whatever you do to one side, you have to do to the other. So now we have x equals, sorry about that, square root of 9. Now we're looking at that before when we had x squared equals 9. What times itself 2 times, that's what that's saying, would give me 9? Well, x could be negative 3, because negative 3 times negative 3 is 9, and it also could be 3. So really we have two answers, negative 3 and 3, because negative 3 times negative 3 is 9, and 3 times 3 is 9. So back into our equation where I'm solving this, we have to have a plus and a minus, because we can have a positive and a negative. So then we have x equals plus or minus, and the square root of 9 is 3, and there's our two answers. Now over here, we're going to do the same thing. We're going to solve for x. And this is saying what times itself, what number squared would give me negative 4. Well, there isn't really a number squared that would give me negative 4, because negative 2 times negative 2 would give me positive 4, and 2 times 2 is 4, so neither one of those would work there. So that means we're going to end up having an imaginary number, because we still have to take the square root to get rid of that square. That's how we get rid of the square. They kind of cancel each other out. So we can just get the x all by itself. Have to have our plus and minus, square root of negative 4. So now we have x equals, and if you remember back in our imaginary numbers, when you have a negative underneath a radical sign, that becomes an imaginary number, square root of 4. So we pulled out the negative, which is just I, imaginary number. And then I'm going to write it up here to give myself some room. So we'd have x equals plus or minus 2i. And how did I get the I? Because our square root of 4 right there, what I'm circling, is 2. So the square root of 4 is 2, so that's how I got the 2. The I came from the negative, had to pull that out, so then there's our two answers there. So we know we're going to have 4 total answers because our original problem up here, what I'm circling right now, was a 4. So that means we're going to have 4 possible answers up there. Now I have a positive 3, negative 3, positive 2i, negative 2i. Now the negative 2i and the positive 2i, they're not really answers on there because they're imaginary, but if we could still graph it, but we're just looking for how to solve these right now. Alright, here's another example here. So we have x to the fourth minus 8x squared plus 15. We're going to factor that. Again, since we have x to the fourth, then we need x squared here and an x squared here, because x squared times x squared is x to the fourth. And in factored form, then this would be minus 5 and minus 3. Again, we're going to set each one equal to 0 and solve for them. So we have plus 5, x squared equals 5. Got to get rid of the square because we're trying to find x only. We're solving for x. Just like in all solving problems in algebra, you're solving for a variable. So we've got to get rid of the square. Whatever you do to one side, you do the other. That cancels those two out. So now I have x equals, have to have your plus or minus. Just from the original slide, I showed you why you had to have a plus or minus. When I did the x squared equals 9. Same reason here. So we have plus or minus the square root of 5. Square root of 5 cannot be simplified any further down. So that is going to be our answer. So there's 2 of our answers. Positive square root of 5 and negative square root of 5. Now I'm going to do it with this equation here with the 3. And again, I'm going to take the square root of them. That cancels those out because you're solving for a variable. So x equals plus or minus square root of 3. Square root of 3 cannot be simplified any further. So that is our final answer for that one there. So again, I have 4 answers. How do I know that? I'm going to have a possibility of 4 answers. Up here at the top of the original, what I just circled, that tells me I'm going to have a possibility of 4 answers. So I have positive square root of 5, negative square root of 5, positive square root of 3, negative square root of 3. So that's how I would solve those there. Alright, we're going to do one more and then we'll go on to our next concept. So we're going to factor that. So you can see then I've already factored that. Save a little bit of time. So the x squared and x squared, why do I have x squared and x squared? Again, because I have x to the fourth. So if it was just x squared instead of x to the fourth, then these right here would only be x's. But since it's x to the fourth, I have to have x squared and x squared. So that's why those are x squared, just like I stated in the previous slides. So now I'm going to solve for those. Alright. So let's see, square root to get rid of the square, inverse, take those out. So we have x equals plus or minus square root of 8. And the square root of 8 can be simplified even further because the square root of 8 has a perfect square in it, which is the square root of 4. So really I have x equals plus or minus square root of 4, square root of 2. And now I can go even further, x equals plus or minus, the square root of 4 is 2, and then I have the square root of 2, so then there would be my answers there. So if you have a radical, you need to see if that radical can be simplified even further by finding out if there's a perfect square in it, just like 8 has a perfect square of 4. And then I'll do it on this side with the 3, x squared equals negative 3. I can see now I have a negative. So I'm going to end up probably going to have an imaginary number because of the negative in there. Just take square root, that cancels those two out. So I just have x equals plus or minus square root of negative 3. Then x equals plus or minus. That negative needs to come out of there because you can't find the square root of negative 3. So that negative becomes your imaginary, the I. Then I just have square root of 3. Square root of 3 cannot be simplified any further. That is as simplified as it'll go. So then that is going to be my answer there. So again, I have 4 answers. Plus positive 2 square root of 2, negative 2 square root of 2. Positive I square root of 3, negative I square root of 3. Alright, our next concept is difference in sum of cubes. So these two equations here, these general equations, you don't have to memorize these, but they are very important. You're going to use those. So we're going to be looking at things that are cubed this time to the third power, and you're going to use one of the two. So either use this one or this one. One of those two, depending on what your equation is. Now the equation I have right here, 8x cubed minus 27. So since it's a minus 27, there are minus in there. It's a difference, it's a subtraction. I'm going to use equation number 2 on there. So we're going to look at this part here, what I'm making in a box here. And we're going to find out what our A is and what our B is. So our A means 8x cubed. What times itself 3 times will give me 8x cubed. So something times something times something, the same thing, 3 times, would give me 8x cubed. Well, that would be 2x. Same thing here with the 27. What times itself 3 times would give me 27? Well, the answer is 3. 3 times 3 times 3 is 27. So that's how I got that. So that's what you're going to be doing for each one of them. So your A is the first one, and then the B is the second one. And it's just a number, don't put the minus in there, anything like that. So now I'm going to use equation number 2, since my problem I'm solving has a negative, or excuse me, a minus in it, difference, subtraction. So I'm going to put my my A and my B into my equation. So the 2x and the 3 in problem number 2. So I have my A, 2x, then there's a minus, my B was a 3, A again, 2x, that has to be squared it says, plus A again, that's 2x, B, that's 3, plus B again, what's my B? 3, and that has to be squared. So my problem then now, to clean it up a little bit, 2x minus 3 times 2x squared. So I'm looking at this right here. 2x squared is 4x squared plus 2x times 3 is 6x plus 3 squared is 9. So that's what I have for now an equation. Now this is all going to be set equal to 0, just like my original equation. So that's how I got the 0 right there. And now I'm going to have to solve these. So I'm going to have 2x minus 3 equals 0. I'm going to solve that. So it'd be 2x equals 3, x equals 3 halves. So There's one answer. Now this one right here, I'd like to factor it to this way, just like I did in the first few slides at the beginning of this lesson. But this one is not factorable. I can't factor this like we normally would. So when you can't factor something, it's not factorable, then you have to use the quadratic formula. So we're going to use the quadratic formula to figure out what my other answers are. Again, I'm looking for 3 answers. How do I know? Because my original equation had a 3 in there, so I'm going to have possibility of 3 answers in there. But since it's not factorable like we're usually seeing, you have to use a quadratic formula in order to do that. And I'm going to do that on the next page to give myself some room. Alright, I'm going to go through this fairly quickly because everybody should know how to use quadratic formula by now. So we got our A, B, C. So we've done this in the past. There's our A, that's our B, and that's our C. So our A is 4, B is 6, C is 9. So I just substitute all those in there in my quadratic formula and solve it. So I have negative 6 plus or minus square root of 6 squared minus 4 times 4, because that's my A. My C is 9. Let's make that 9 a little bit better. All over 2 times 4. So that equals negative 6 plus or minus 36 minus, let's see, what is that, 144 all over 8. So we have negative 6 plus or minus square root of negative 108 all over 8, which then gives me negative 6 plus or minus, I see I have a negative underneath my radical sign, so just like we've done in the past, anytime you have a negative underneath your radical sign, bring that out, and that's your I, which is 108 then, underneath, all over 8, which equals negative 6 plus or minus I. Square root of 108 has a perfect square in it, which is 36 times 3, and that's all over 8. And I'm going to go to the next page to give myself some room there. Alright, so I just brought over those equations from the other page to give myself some room. So the 108 broke down to square root of 36 and 3. So now I have negative 6 plus or minus the I square root of 36. Square root of 36 is 6. So I have 6I square root of 3 all over 8. So now I'm going to look to see if I can reduce that. So the 6 came from the square root of 36. So I look this way. That can be simplified, and so can that. 2 will go into both of those in there. So I'd have negative 3 plus or minus 3I square root of 3 all over 4. Because negative 6 over 8 is negative 3/4. 6 over 8 is 3/4. So that's how I got those. So that's from the negative 6 and 8, and that's from the 6 and 8. So that's how they got those. So that would be my final answer there. I'll take those back off so you can see that. So there's my other answer. So I had negative 3 plus 3I square root of 3 over 4, negative 3 minus 3I square root of 3 over 4, and if you remember, I also had the 2x minus 3 equals 0, and found out that x equals 3/2. So there's my 3 answers. How do I know I have 3 answers? Because we're working with cubes, so I can have a possibility of 3 total answers on there. Alright, we'll do one with an addition in there. So let's see, we have to find our A. So we're looking at this right here. Again, what times itself 3 times would give me 8x cubed. Would that be 2x? What times itself 3 times would give me 125. Well, that is 5. So that's my A and B. Now, since I'm using a plus in there, if you go back to the original, or the couple slides back, you'll find out those 2 formulas that you really need to learn and understand. So we're going to be using the A cubed plus b cubed, which was number 1 on that slide. So that's a plus b and a squared minus ab plus b squared. So we're going to be using that equation there. So all I'm going to do is take my a, which is 2x, my b, which is 5, and substitute those in there and then solve them. Alright, so I have 2x plus 5, because 5 is my b, 2x is my a, and times a squared, well what's my a? 2x, so I have to square that, minus a, what's my a? 2x, times b, what's my b? 5, plus b squared, my b is 5, so I have to square that. Alright, so clean it up a little bit, 2x plus 5, and 2x squared, so right here, 2x squared, that's going to be 4x squared, minus 2x times 5x is, or excuse me, 2x times 5 is 10x, and 5 squared is 25. So there I have my equations, so we're going to set each one of those. We're going to solve for them. So we have 2x equals negative 5, and divide by 2, x equals negative 5 halves. So there's one, that's the easy one, that doesn't take any time at all. Again, we'd like to factor this, it's a lot easier if we can factor and solve for them, but again, it's not factorable. So we're going to have to use the quadratic formula. And I'm going to do that on the next page. Most of these are not going to be factorable, so you're probably going to have to just about, I think all of them, do the quadratic formula on there. So I'm going to go to the next page and solve for that one. Alright, so you can see I've already done some to save time once again. So I found my A, 4, B, negative 10, C, 25. So that was my A, B, C, because I need those for my quadratic formula. I've already substituted all those in this equation right here. And then I started solving, so now I'm down to the second line, this one right here. So I have 10, because I had negative 10, because the equation formula has negative, and my b is negative, so that's why it's negative 10. And I have negative 10 squared, which is 100, minus 4 times 4 times 25. Alright, so I got that, and then when I went down to my third line there, I have 10 plus or minus negative 300 over 8. So there's a negative, so that means I'm going to have an I. So now I have 10 plus or minus I, because I'm going to take out that negative, 300 all over 8. And I'm going to go to the next page, the next slide, to give myself some room here. Alright, so I have my equation there. And I'm going to continue to solve it. So I have 10 plus or minus I. 300 has a perfect square in it. 103. Square root of 100 is a perfect square. So that's going to be, that's what I had to find in order to solve that. So you always have to simplify. So you always have to look to see if there's a perfect square. Do not leave it as square root of 300. You need to solve it, simplify it down as far as it'll go. So I have 10 plus or minus square root of 100 is 10. I have my I, then I have my square root of 3 all over 8. Then one more thing, and change colors here. I'm going to simplify that, so I look this way. 10 over 8 simplifies to 5/4. 10 over 8 is 5/4, so I have 5 plus or minus 5i square root of 3 all over 4. So there is my last two answers. So you remember I had from the other one 2x plus 5 equals 0, and x was negative 5 halves. So there was 1 from the previous slides. And then I have two more answers, 5 plus 5i square root of 3 over 4, 5 minus 5i square root of 3 over 4. So I have 3 answers. Why do I have 3 answers? Because I could have a possibility of 3 since I was using cube. Because remember in our Original equation was 8x cubed. Since we're working a cubed, our possibility is to have 3 answers. So those are all the examples I have for this lesson of quadratic techniques. Make sure you simplify everything. Make sure you listen to it, go back to it, try some problems out, take notes, and just do your best you can. And good luck to you. Bam!